Hi everyone, this video is Cambridge Primary Mathematics Learners Book 6, Unit-2, Subtitle 2.1 Counting and Sequences and Exercise 2.1. အားလုံးပဲမင်္ဂလာပါဒီဗီဒီယိုလေးကတော့ Cambridge Primary Mathematics Learners Book 6, Unit-2 ရဲ့ first part ဖြစ်ပါတယ် part 1 ဖြစ်ပါတယ် subtitle 2.1 Counting and Sequences နဲ့ exercise 2.1 တွေကို share လုပ်ထားတာဖြစ်ပါတယ်အားလုံးပဲအသုံးဝင်ပါစေ So this is unit 2 main title is numbers and sequences. There are three subtitles 2.1 counting and sequences, 2.2 special numbers, 2.3 common multiples and factors. And in this video, I'm going to share only about this first title 2.1 counting and sequences and exercise 2.1. Okay. Let's get started. Getting started is to warm up your last year knowledge. Okay. Number one, these patterns of dots show the first three square numbers. The first three square numbers. This is keyword. First one is 1, second one is 4, and third one is 9. So they are 1 square, 2 square, and this is 3 square. Okay, next one is write the first 10 square numbers. 10 square numbers. So next one is 4 square is 16, 5 square is 25, 6 square is 36, 7 square 49, 8 square 64, 9 square 81, and 10 square is 100. This is number one. Number two, give the first term and the term to term rule. Term to term rule is you have learned in your last year. First term and term to term rule, write down the first 6 terms of each sequence. So we have to continue up to 6 terms. So first term is 4, term to term rule is S7. So first term is 4, at 7 is 11, another 7, 18, another 7, 25, another 7, 32, another 7, 39. 1, 2, 3, 4, 5, 6. This is ours. Part B, first term is 2, term to term rule is at 9. Okay, first one is 2 plus 9, 11, plus 9, 20, plus 9, 29, plus 9, 38, plus 9, 47. 1, 2, 3, 4, 5, 6. Okay. Number 3, the numbers in this sequence increase by equal amounts each time. Equal increase means we have to add up a number equal amount each time. What are the 3 missing numbers? We have to fill these 3 numbers. Okay, first one is 1 and last one is 13. So first step is we have to take the difference between them. 13 minus 1 is 12. And let's count how many gaps are there. There are 1, 2, 3, 4, 5. 5 numbers, so the gap is between them is 4 gaps. 1, 2, 3, 4. So each gap is how much? We have to divide 12 with 4 gaps. So 4 times 3 is 12. Each gap is 3. So it means we have to add up 3 at 3 each time. Okay, 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. So our sequence is correct. Number 4, here is a set of numbers. 2, 4, 6, 12, 24, 36, 48. Okay, part A. Choose 3 multiples of 12 from the set. Multiples of 12 are 12 times 1, 12 times 2, 12 times 3. Okay. Multiples of 12 are, we can see 12 and 12 times 2 is 24 and 36 and or 48. We have to choose only 3 multiples. So 36 or 48. But we choose 3 factors of 12 from the set. Factor of 12 are 1 times 12, 2 times 2, no, sorry, 2 times 6, 3 times 4. Okay, so we can see 2 and 4 and 6 and 12 are 2, 4, 6, 12 are factors of 12. So we have to choose 3 of them. So we can choose 2, 4, 6, or 12 itself. And this is number 4. So look at these sequences. Sequences are if they increase an equal amount or if they decrease an equal amount, these are increase equal amounts. So 2, 4, 6. And this is increasing in these are example of sequence. And look at these two sequences. So first one is start from 5 and next term will be S2. So 5, 7, 9, 11, 13. So our term to term rule is plus 2, H2. And the second one is 71, 65. So it decrease. So we have to subtract a number, -6, -6. So term to term rule is subtract 6. So here is term to term rule is H2 and here is term to term rule is subtract 6. Therefore, term to term rule. So we use term to term rule to find our next number in our sequence. So can you think of other examples of sequences? Okay, please think us up. And in this unit, we will explore sequences of numbers and different types of numbers. Numbers and different types of numbers and including square and cube numbers, common multiples, and common factors. Okay. This is the main subtitle for this video, 2.1, Counting and Sequences. Counting and sequences, we are going to count on and back. Do you remember? Count on is we have to add a number and count back is we have to subtract a number using fractions and decimals. Okay, fractions and decimals. And we are going to find and use the position to determine. This is new word for Q position to term rule. Last year, you knew only term to term rule. Now, position to term rule of a sequence with volume. Okay. So in stage 5, we learned how to use a term to term rule to find the next term in a sequence. And in this unit, we will learn how to use the position to term rule. Position to term rule to find any term in the sequence. So we can find anywhere, any term easily by using this position to term rule, okay? So keywords are position, position to term rule, term and term to term rule. So this is example. If the sequence is 4, 8, 12, 16, okay? So we make a table like this, term and number. There are 4 terms, 1, 2, 3, 4. Numbers are 4, 8, 12, 16. So term 1 in term 1 first and meaning first position number is 4. So 1 can be 4. We can times 1 times 4, 1 can be 4. And this way, if 2 times 4, we get 8. And 3 times 4, we got 12. And 4 times 4, we got 16. So if we multiply 4 with our positions, we can find our sequence numbers, okay? So our sequence is 4, 8, 12, 16 is adding add 4 each time. 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16. And We find first position times 4 is 4. Second times 4. The 2 times 4 is 8. Or third, 3 times 4, 12. So if we multiply our position with 4, means multiply by 4, we can find our any term in our sequence. So the 25th term is 25 times 4, it is 100. So 25th is far away from 4, but we can find easily like this when we know our position to term rule multiply by 4. Okay, if our term is 30th term, so we can find 30 times 4, it is 120. So if we know our position to term rule, we can find easily any term in our sequence like this. Okay, work example 1. Work example 1. Follow the instructions in the flow diagram to generate a sequence. This is a flow diagram to generate a sequence. Let's start. Write down 2. Write down 2 and add 2. So we got 4. And check, is the answer more than 20? Not more than 20, no. We write down the answer and add 2 again. Okay, our answer is 4, less than 20, so add again, or 8, less than 20, 8, again 10, 12, 14, 16, 18, 20. This is our sequence. So part B, this is generate a sequence using this flow diagram. And part B, what is the position to term rule for the sequence? If we want to find position to term rule, we have to make a table with our position and our numbers, okay? Part C, imagine the sequence continues forever. What is the 50th term in the sequence? Okay, let's see our terms in the table. This is part A. Answer is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. They are multiples of 2. And follow the instruction in the flow diagram. We include 20 because it is not more than 20. So we include 20 in our sequence. And for part B, we have to make a table to show the position and the term. Position is 1, 2, 3. We can check 1, 2, 3. Only 3 terms. From these 3 terms, we can check. We don't need to write down all the terms. Okay, position 1 is 2, 2 is 4, 3 is 6. So 1 becomes 2 is 1 times 2. So 2 becomes 4 is 2 times 2. 3 becomes 4 is, 3 times, 3 becomes 6 is 3 times 2. Okay, so our position to term rule is multiply by 2. So multiply by 2, we can find any term in our sequence. Okay, look how the position number is connected to the term number. So we can multiply our position number with 2. We can find our any term in our sequence. So the position to term rule is multiply by 2. This is the answer. Multiply by 2 is our position to term rule. Use the position to term rule to find the 50th term. So for 50th term, 50 times 2 is 100. This is our 50th term. So you can find easily like this. This is exercise 2.1. Number 1A, find the position to term rule for the numbers in this table. So there are 4 terms. 1 becomes 6. So 1 becomes 6 means 1 times 6. So let's check second one. 2 times 6 is 12. Okay, 3 times 6 is 18. 4 times 6 is 24. Okay, so our term to position to term rule is multiply by 6. Okay, what is the 10th term of the sequence? 6, 12, 18. So our 10th term is position 10 times 6. So 60 is our 10th. This is the answer for part B. Number two, the numbers in this sequence increase by equal amounts each time means we have to add a number equal number each time. Write the three missing numbers. Just like the example, okay, there are 1, 2, 3, 4, 5 terms. 5 terms, the first one is 3, so last term is 15. So first step is we have to take the difference between them. 15 minus 3 is 12. Now there are 5 terms means there are altogether 4 caps. 1, 2, 3, 4, 4 caps. So we have to divide 12 with 4. So each cap is 3. So it means that we have to add 3 each time. So 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15. So hopefully our sequence is correct. Part B, what is the term-to-term rule for the sequence? For the term-to-term rule, term-to-term rule is it's clear that add 3. And what is the position-to-term rule? Position to term rule. So the difference between term to term rule and position to term rule is, term to term rule, we can find only our successive term or next term, only next term. But we can find any term anywhere. But if we use position to term rule, we can find any term anywhere. Okay, so position to term rule, we have to draw a table for 1, 2, 3 terms. So let's write them here. 3, let's see. So in position 1 is 3. Position 2 is 6. And position 3 is 9. So 1 becomes 3 means 1 times 3. 2 becomes 6. 2 times 3 times 3. They are multiple of 3. So our position to term is multiply by 3. For term to term, we can add each time 3. Number three is just like the example. Follow the instructions in the flow diagram to generate a sequence. So we write down 8. We start from 8 and at 8. So next term is 16. And check, is the answer more than 50? No, we write down the answer in at 8 again. So 16, 24, it means they are multiples of 8. 32, and so 40, 48. So another term is 56. So we stop here, 48. Okay, part B, this is answer for part A. This is, we are generating a sequence by using this flow diagram. Part B, what is the position to term rule for the sequence? Position to term rule, we have to write down as a table. Position 1 is 8, position 2 is 16, 3 is 24. Okay, so 1 becomes 8 times 8. 2 times 8, 16. 3 times 8, 24. So our term position to term rule is multiply by 8. And part C, imagine the sequence continues forever. What is the 50th term in the sequence? So our 50th term, we have to first write down our position 50 and times 8. 0, 5 times 8 is 40. So our 50th term is 100. Okay, number 4 here is the start of a sequence using rectangles and triangles. Each rectangle is numbered. So look here, this is first position, second position, third position. First position, there is one rectangle. Second position, two rectangles, three rectangles. It means that position and rectangles are the same. So for rectangle, sequence is 1, 2, 1, 2, 3, 4. And let's count our triangles. First position, two triangles, two triangles. Second position, four triangles. Third position, six triangles. So triangles are uh, increased to each time. 2, 2, 4, 6, next one will be 8. Rectangles are increased one each, one each. Each time one increase, one each time. So the sequence continue in the same way. So how many triangles are there in the shape with 50 rectangles? How many triangles are there in the shape with 50 rectangles? So for the 50 rectangles, so uh, how many triangles are there in our sequence? So first we use the table to find our position and turn. So this is rectangle is position 1, 1, 2, 2, 3, 3. And triangle is position 1, 2, 2, 4, 3, 6. And total, so the sequence is, compound sequence is for the rectangle and triangle together. First position has one triangle and one rectangle and two triangles. 1, 3, 2, 6, 3, 9. So for part A, we can find two ways with two methods. First, for 50 rectangle means our position is our position is position and term are the same. So 50 rectangles means our position is 50. For 50th position, our rectangles are 50 rectangles. So for 50th position, this is rectangle, and how many triangles are there? So let's check position to term rule for triangles. 1 becomes 2 is times 2 times 2. So for triangles, we have to multiply 50 with 2, so it is 100. So there are part A, how many triangles are there in the shape with 50 rectangles? For 50 rectangles, there will be 100 triangles. By checking our position determined like this. And how many rectangles and triangles are there altogether in that shape? In that shape, total shapes, so we have to use total position and term. This is for the whole sequence, position and term. Position 1 is 3, 2 is 6, 3 is 9. So 1 becomes 3, 1 times 3. 2 becomes 2 times 3, 6. 3 times 3, 9. Okay, so our position to term rule for the whole sequence is whole sequence is multiplied by 3. So for the altogether in this shape means in the 50th term. So in the 50th term, we have to find position is 50 and times 3. So we can see 5 times 3, 50, 150. So it means that there are 50 rectangles and 100 triangles. Altogether, 150 is our 50th term. Okay. Part B, Judy starts to make a table showing the position, shape number, and the term total number of rectangles and triangles. Copy and complete her table. It's easy. We have done once. So first position 3, 2. Our term to term rule is, position to term rule is, do you remember? Multiply by 3. Okay, 1 times 3. So 2 times 3 is 6. And 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 50. We have the 6 and 50 like this. Part C, what is the position to terminal for Jody's sequence? Position to terminal is multiplied by 3. What is the 50th term in the sequence? Check your answers with your partner. 50th term is position 50 and times 3, it is 150. Number 5, Pablo counts up in quarters. Quarters mean we have to use fraction 1/4. What are the two missing numbers? Now counts up means we have to add 1/4 each time. 1/4 half, 3/4, 1, another one is 1/4, 2.5, and another one is, sorry, 1.5, then 1, 3, 4. Number 6, write a sequence with steps of constant size. Steps of constant size, it means the same as we add up or subtract equal amount each time, in which the first term is 1 and the fifth term is 1.0. This is 1 and this is 1.04. So just like before, we take the difference between them. 1.04 minus 1 is 0.04. There are 4 gaps, 1, 2, 3, 4. So we divide 0.04 with 4. So we got 0.01. So our second term will be 1.01, 1.02, 1.03, 1.04. And part B, what is the 10th term? So this is our fifth term. Our fifth term is 1.04 less than 1, less than 5, 1 less than 5. It is 4. So you can find easily our 10th term will be 1.0. Okay. Second, only runs a number sequence starting at 15 and counting back. Counting back. Counting back means is subtract a number in steps of 0.4. Counting back 0.4, subtract 0.4 each time. So 15, 14.6, 14.2, 13.8. So he says 1.5 cannot be in my sequence. Only is correct. How do you know without counting back? Discuss your answer with your partner. Okay, if we subtract, another one will be 13.4. Another one will be 13. Another one will be 12.6. Okay, so check the tens places. Tens. All the tens places are even. Okay, and 1.55 is odd. So 1.5 cannot be in this sequence because the tens place must be always even. Okay, so our answer is all the 10 stages are even and 5 is odd. So what Oli says is correct. Number 8, Hassan comes back. Hassan comes back means subtract the number in steps of 2/5. Subtract 2/5. Starting at 0. He can't 0, blah, blah. So which of these numbers would Hassan say? So we continue our sentence sequence and check from these numbers, which ones are included in this sequence. So -1, 1/5, subtract 2/5, it becomes negative. It is count back, but count back is we have to add a negative number each time. We add 2/5 each time. So -1, 3/5. Next one, -2. And -2, 2/5. And again, -2, 4/5. And negative 3 1/5, and negative 3 plus 2, negative 3 3/5, and another 2/5. We got negative 4. Let's stop here because negative 4 is here. So negative 4 and 3, negative 3 3/5, 3/5. Yes, it's included. And negative 2, negative 2. So which of these numbers could Hassan say is negative 2, negative 3 3/5, and negative 1? 3 numbers. Number 9, Samira counts on. Counts on from 20 in steps of 1.001. So her sequence is 20, 21.001, 22.002, 23.003. So write the first number Samira says, which is bigger than 30. Bigger than 30 means, let's check 29. Let's check 29, 29.009. So we add 29.009 plus 1.001. Okay, 91 is 10, 0, 30. Okay, first number, which is bigger than 30 is this one, 30.01. This is the answer. The last part of this subtitle, think like a mathematician. The diagram shows the first 5 hexagonal numbers. First 5 hexagonal numbers, 1, 6, 15, 28, 45. So how does the sequence continue? How does the sequence continue? Okay, so we have to find out turn to turn rule or position to turn rule. Then, in this case, we can check by finding our turn to turn. Okay, 1 and 6. 1 and 6. So this is plus 5. And 6 and 15. 6 and 15 plus 9. And 15, 28. Again, plus 15 and 28 plus 13. And 28 and 45 plus 17. Okay, let's check. 5 and 9 increase 4. 9 and 13 increase 4. 13 and 17 and increase 4 again. So another term will be 17 plus 4 is 21. So we have to add 45 with, we have to add 45 with 21. We got 66. Our next number in the sequence will be 66. 66. So how happen? Let's see how they happen in this figure. Okay, this is 1 first. And 6, 1, 1, 2, 3, 4, 5, 6. So the difference, the increase is 5 increase, so altogether they become 6. This is 6. And another 5 becomes 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. Altogether they becomes 15. And again, another, here are 13. 13, so they become this sequence. This number is 28. And again, this is 21 altogether. From here to here, 21. So altogether 45. And next one is from here, it is 66. Okay, this is our first part. Our next term is 66. Write these numbers as the sum of 2 hexagonal numbers. Just like 12, 21. This is 39, not 39. This must be 29. You can do 39, 29, 30. Okay, the first one is done for you. 12 is 6 plus 6. We have to use these numbers. Okay, 21 is 6 plus 15. and 28. 28 can be, 29, sorry. 29 can be 1 plus 28. And 30. 30 can be 15 plus 15. Okay. Okay, we can do like this. And investigate which are the numbers less than 100. Can be written as the sum of two hexagonal numbers. So first, up to 100, other hexagonal numbers are up to 66. There is only one more, 91. So how can we do 91? Let's check. Let's check. Okay. So by using these numbers, our hexagonal numbers in figure is this, let's see. This one, and second one is 1, 2, 3, 4, 5, 6, 6, and 6, and 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And here is 28, 28. Here is 29. Okay, our sequence numbers are 1, 6, 15, 28, 45. They have like this. Okay, but what I can do, I can count on and back using fractions and decimal. Yes, we can. We can count on and back by using fractions and decimal. Yes, I can find and use the position to turn rule in sequence. Yes, we can find. Okay. Okay, this is N4. First title. First subtitle 1.2. Count and sequences. Thank you so much for your attention and for your watching. See you in the next video. In the next video.